Hello, we're going to talk about this command right here from pprint, import pprint as pp, because this has two really cool programming features tucked into it. One is functions and the other one is modules. So if we run this and then actually use it like we have before, then we'll see in our global namespace all of the names that we've defined. And since this is a fresh REPL session, the only name that I've defined is pp, which is a function. We can verify that with type pp. Now, a function is, as you can see over here, it's something that responds to data. I like to think of it as a machine, whereas a variable takes in a number and then it keeps that number. It stores the data, or not just a number, but any value of some kind. A function will maybe take in a value. You can see sometimes it doesn't require that, but it will output something as well. Maybe data, maybe the output is just the change in state of the system itself. So functions in Python and in most programming languages must have these parentheses here. So type is a function. We've seen print, which just prints out the value of a variable or whatever really you put inside there. Pprint does the same thing. I mistyped a little bit there. But it pretty prints a big data structure like this, which we'll get into later. As you can see, pp and print both require at least one argument here, or one input. If you try to run it without an input, it says missing one required. We'll talk about the word positional later. Argument. You can't just run pp or pprint by itself like you can globals. If you run globals by itself, it'll output all of this. So what we have been doing is we're taking the output of globals, which is all of this part here, and we're pumping that output of globals into the input of pp. So that is a way to, I like to call it daisy chaining to functions. We're taking the output of one function, pumping it into the input of another. We'll see that countless times again and again. So we've talked about what functions are here, but there's some more stuff in here, which is what I call modules. So let's use a different example. Let's do import math. We've done an import statement before. And now if we do pp globals, we'll see that math is imported into our global namespace. And it is a module. We can verify that with type. So math is a module. What is a module? If you look at this little graphic I've made, variables store data, functions respond to data, but modules encapsulate data. So a module is just a collection of functions and variables. And if you want to know what's inside that module, you can do dir, which we've done before. Dir normally by itself with no inputs outputs what all names we have in our namespace. But if you send in the name of a module as the input of the dir function, then it shows you all of the functions and variables associated with the math module, or whatever module you send to dir. So let's look at this. Oh, pi, that might be helpful. I don't want to type 3.14 every single time I want to use pi, so let's try that. Oh no, pi is not defined. Well, let's try pp globals again. You can see that there's no pi in here, just the three names that we've defined so far. And that's actually a good thing because the module encapsulates the data like this so that we don't have to see it clogging up our namespace. But in order to access it, we need to write the name of the module that it's inside, hit the dot operator to drill down into the module, and then we can use pi there. We can also access tau, we can also access e. These are all floats. These are all variables, okay? However, there are some really nice functions like squirt. So let's try squirt. And hopefully you might be able to figure out what this is referring to. And since it's a function, we need our parentheses. Let's try that. Oh no, it takes one argument. Well, we could start pumping in arguments or parameters or inputs to this function and see what happens. But we could also run help and use math.squirt as the input to the help function. So let's try that. Okay, look, it says it returns the square root of x. Okay, well, that's seems to be what it's verifying here. What if we did the square root of pi? Okay, cool. I'm guessing that's what it equals to. I don't really know. So we can use math.squirt as a function, math.pi. We can use all of those functions and variables in here. But if we did want it to be shorter, I mean, math.blah, blah, blah is kind of long. We could do from math import pi. And now if you look at pp globals, you'll see that pi is in fact a variable in our global namespace. And so now we just need to hit pi and not math.pi, although both actually work in this case. So what we're doing with from pprint, import pprint as pp is one step further than from math import pi. So from pprint is the name of the module. We imported pprint, which is confusingly in this case also the name of a function. So if we didn't do this long thing, we would have had to say pprint.pprint to reference that function. But we did another cool thing, which is as. So we importing the function pprint and just slapping a new name on it, pp. So now I can use pp.